Hello everyone. Today's video is about a very interesting maths challenge. Have a look at the question on your screen. We have to sum up the following series. 1 into 2 plus 2 into 2 square plus 3 into 2 cube plus so on up till 9 into 2 raised power of 9. On the face of it, it looks like a simple question. We can easily guess that there are a total of 1 to 9 terms, and most of us also remember powers of 2. So if not anything else, we can just calculate the value of each term and that's it. Add up the 9 values. So for instance, 4 into 2 raised power of 4 is equal to 4 into 16, that is 64. The last term is 9 into 2 raised power of 9. That is 9 into 512, which is equal to 4608. But the real challenge comes when I extend this series by 3 to 4 more terms. Our calculations increase many-fold. Therefore, we must try to find out a simpler way of doing this question. And this video lesson deals precisely with this task at hand. Let us begin. You may grab a pen and notebook and try finding the answer. And once you are done, let's discuss. To solve this question, we must look at the pattern closely. Each term, and this is one term, this is another, and so on. This one is last. So each term has two components. The first ones are numbers from 1 to 9. These ones. They are consecutive natural numbers. And the second ones are 2 raised power of 1, 2 raised power of 2, 2 raised power of 3, and so on up till 2 raised power of 9. They are successive powers of the number 2. So if we have to write down the formula for a general term of this series, say the nth term, it will be Tn, which means the nth term is equal to n into 2 raised power of n. Next, we will do a simple trick to find our answer. Let us denote the sum of this series by S9 because there are a total of 9 terms in this series. So S9 is equal to 1 into 2 plus 2 into 2 square plus 3 into 2 raised power of 3 plus 4 into 2 raised power of 4 plus so on up to 9 into 2 raised power of 9. The first step is to multiply both sides of this original equation with the number 2. So S9 multiplied with 2 becomes 2 into S9. On the right hand side, just remember one thing. When you multiply each term with 2, shift them one position to their right before writing them down. So 1 into 2 multiplied with 2 becomes 1 into 2 square. We shifted one position to the right before jotting it down. 2 into 2 square becomes 2 into 2 cube. We write that. 3 into 2 cube becomes 3 into 2 raised power of 4. We write that. The second last term becomes 8 into 2 raised power of 9. We write it below 9 into 2 raised power of 9, which was the last term of our first equation. And this very last term, when multiplied with 2, becomes 9 into 2 raised power of 10. This is the last term of our second equation. Next step is to subtract both equations. And now you will understand why we shifted each term one place to the right. The left hand side looks like, and look here, since 2 minus 1 is 1, so is 3 minus 2, it's 1, so is 4 minus 3 and so on, 9 minus 8. All of them are equal to 1. I can spot successive powers of 2 here. 2 raised power 1 up till 2 raised power of 9. This series is a geometric progression. I simply apply the formula and the sum of this series will turn out to be 2 raised power of 10 minus 2, which in turn is equal to 1022. Moving on, we just need to simplify this equation a bit further and evaluate S9, the sum of our required series. The sum of powers of 2 from 2 raised power of 1 to 2 raised power of 9 is 1022, as we just calculated. 9 into 2 raised power of 10 is equal to 9 into 1024. 2 raised power 10 is 1024. So S9 is equal to 9216 minus 1022. And thus we have found out the answer for our question. The answer is 8194, 8194. We can extend this formula, this concept for n terms. And following the same procedure, we infer that if the last term of this series is n into 2 raised power of n, then Sn, which denotes the sum of n terms of this series, is equal to n minus 1 into 2 raised power of n plus 1 plus 2. That brings us to an end of this video lesson. If you enjoyed this math challenge and found it useful, don't forget to press the like button and also do subscribe our channel IPM Leap. Here is a glimpse of other popular maths videos on our channel. So keep watching and take care. Bye-bye.